Blessed day to all the participants of the Division Webinar on ICT. I am Ronnie Gonzalez from Southville 8B National High School. Unlike the usual demo teaching that we know, this time I will be showing a learning process from a student view. I hope this session will impart ideas and techniques to all of you. In your previous grade level, you have learned how to solve first-degree equations in one variable. These equations with the highest exponent of 1 is called linear equations. For example, the equation x plus 5 equals 0 is a first-degree equation in one variable and considered as a linear equation. Let us try to identify which of the following mathematical equations are linear equations. Are you ready? Okay, let's start. So the first equation here is x squared plus 5x plus 2 equals 0. Is this a linear equation? Yes, it is not a linear equation. How about 9 minus 4x equals 5? Yes, it is a linear equation in one variable because the highest exponent of x is 1. How about this equation? Yes, it is also not a linear equation. How about this one? Okay, it is also not a linear equation. And 6p minus 9 equals 12 is a linear equation. Okay, so let us finish the last 5. This one is a linear equation, but this one is not. X minus 14 equals 0 is also a linear equation. How about 5y squared plus y plus 7 equals 0? Yes, it is not a linear equation. And the last one is a linear equation. If the set of equation inside the box is linear, how about the other set to the left? What do you call this kind of equations? Did you observe something? How they differ? Actually, these equations are called quadratic equations. So let me read the definition of a quadratic equation. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form. Ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Okay, in the first example, we can see that the variable used is x and the highest exponent is 2. And in the second example, the highest exponent is also 2. In the third example, the variable used is a. But as you can see, the highest exponent is still 2, as well as the fourth and the fifth examples. Okay, let us have another example. Let us try to identify which of the following equations are linear and which are quadratic. Okay. So examples 3 and 5 are linear since the highest exponent of the variable x is 1. Examples 1 and 2 are quadratic because the highest exponent of the variable x is 2. Example 4 is neither linear nor quadratic. As we can see, the highest exponent here is not 2 because x cubed has an exponent of 3. Let us continue our discussion about quadratic equation. We have learned that the standard form of a quadratic equation is ax squared plus bx plus c equals 0. Now, a quadratic equation is also divided into three parts: the quadratic term, the linear term, and the constant term. The quadratic term is represented by the ax squared, the linear term is the bx, while the constant term is c. So let's learn more about these three parts. I have here 5 examples of quadratic equations in standard form. So all we have to do is to find the value of a, b, and c of each of the following. So let's start with the first example. X squared minus 7x plus 2 is equal to 0. So take note that in this example, the quadratic term is x squared, the linear term is negative 7x, and the constant term is 2. So to find the value of a, all we have to do is to look for the coefficient of x squared. In this case, the answer is 1. And for the value of b, we need to find the coefficient of x in the linear term. And in this example, of course, the answer is negative 7. And for the constant, the answer is 2. Now, the question is this. Is the equation quadratic? Of course, it is a quadratic equation because the highest exponent is 2 and a is not equal to 0. In the second example, negative 2k squared plus 12k minus 1 equals 0, the value of a should be the coefficient of the quadratic term, which is negative 2k squared. So, a is negative 2. And for the value of b, we need to look for the coefficient of k in the linear term. So, of course, the answer is also positive 12. And the constant in this equation is obviously negative 1. So take note of the sign of each term. Is the equation also quadratic? Yes, it is also a quadratic equation. Let us move on with the third example. Can we still prove that 8x squared plus 21 equals 0 is a quadratic equation? Okay, we can do that if we find the values of a, b, and c of the equation. So in this example, the quadratic term is 8x squared. It means that the coefficient here is 8. So the value of a is also 8. How about the value of b? Take note, if the linear term is missing, it means that the coefficient of the variable is 0. So the value of b here in this example is 0. And the constant is 21. So, is this a quadratic equation? Yes, it is a quadratic equation. In the fourth example, which term do you think is missing? That's right. The constant term is missing. So, we can say here that the value of c should be 0. But, because we have here the quadratic term which is negative x squared, therefore, what is the coefficient of x squared? Okay, we cannot see any number, but we can say that the negative sign here represents negative 1. Okay, and for the linear term, we have 5x, therefore the value of b is 5. And is this a quadratic equation? Absolutely yes, because a is not equal to 0 and the highest exponent of the example or the quadratic equation is 2. So this is really a quadratic equation. The last example is obviously not a quadratic equation. Why? Because the quadratic term in this equation is missing. Therefore, if the quadratic term is missing, we can say that a is 0. And if a is equal to 0, therefore, the equation is not a quadratic equation. Though b is 5 and c is 2, we cannot say that this is a quadratic equation because take note of the definition of the quadratic equation. It should, the value of a should not be equal to 0. So the fifth example is obviously not a quadratic equation. Let us have another examples. This time, the equations are not in standard form. So let's start with the equation in the left part of the slide. 12x minus 9x squared plus 9 equals 0 is obviously not in its standard form because the quadratic term should be at the beginning of the equation. So, in rewriting the equation, we will have negative 9x squared plus 12x plus 9 equals 0, and it will be easy for us to identify the value of a, b, and c in this way. The second example is transformable into a quadratic equation. Let's find out how. First, we need to multiply 5x and x minus 3. We will have 5x squared minus 15x equals 6. So let us make one side equal to 0 by transferring 6 to the other side. And now we have the equation as 5x squared minus 15x minus 6 equals 0, which is in standard form already. In the equation, the value of a is 5, the value of b is negative 15, and the value of c is negative 6. Let us transform this equation in standard form so we can get the value of a, b, and c. First, multiply negative 4 and x minus 5. Then, after multiplying and having this equation, we need to simplify the right side of the equation, which is 7 minus 9. And the answer is negative 2. This negative 2 should be transferred to the other side so that the equation or the right part of the equation will be 0. And by combining like terms, we will derive in this equation, which is the standard form of the equation before, where a is negative 2, b is negative 4, and c is equal to positive 22. Our next lesson is about solving quadratic equation. Solving quadratic equations means solving for the value of the variable that will make the equation true. For example, x squared plus x equals 12 has two solutions, which are 3 and negative 4. 3 and negative 4 are solutions of the equation because if we substitute 3 and negative 4 to the variable x, the equation is always true. There are several methods in solving quadratic equations, but in this lesson, we will focus on factoring. In factoring, you must know first if the equation is factorable because not all quadratic equations are solvable using factoring. Later, we will understand how to identify factorable quadratic equations. But before that, let us learn this complete form and incomplete form of quadratic equations. If the value of a, b, and c of a quadratic equation is not 0, then this quadratic equation is incomplete form. But if the constant term or the value of c is 0, then the quadratic equation is incomplete. Now, let us study the steps in solving quadratic equations by factoring in incomplete form. There are only two steps. The first one is to factor out the variable, and the second one is to apply the zero product property. Now, what do we mean by the zero product property? If the product of A and B is equal to 0, then either A is equal to 0 or B is equal to 0, or both A and B are equal to 0. In short, if a product is 0, then either one of the factors is 0 or both factors are 0. So let us have these examples. So in the first example, the factors are x minus 4 and x plus 3. By using the zero product property, we can say that either one of these factors is equal to 0. So we can solve x minus 4 as 0 or x plus 3 equals 0. If we let this factor is equal to 0, then our x should be 4. And if we allow that this factor is 0, then we will have negative 3 as the value of x. In the second example, the factors are x and 2x minus 9. So by using the zero product property, we can write this equation into x equals 0 and 2x minus 9 equals 0. And by solving these two equations, the answer must be x is equal to 9 over 2 or x is equal to 0. Let us solve this example by factoring. So the first step is to factor out x. In factoring out the variable, it is also needed to find the highest number where the coefficient of the terms are divisible. 6 and 8 is divisible by 2. Therefore, we will factor out 2x. And if we divide 6x squared by 2x, we will have 3x inside. And if we divide 8x by 2x, the answer will be 4. Now, by applying the zero product property, we will easily find the value of x. And the solutions are 0 and negative 4 over 3. These are the steps in solving quadratic equations by factoring for complete form. So first, we need to transform the quadratic equation to standard form. Then multiply the value of a to the value of c, or the constant. Then the third one is to find the factors of the resulting product with the sum equal to the value of b. Then by using this formula and simplifying the equation by using the zero product property, we will have the solution in every quadratic equations that are factorable. Let us solve this equation by factoring. The equation is already in standard form, so all we have to do is to multiply a and c. In our example, the value of a is 1 and the value of c is 18. Therefore, the product is 18. Now, we need to find the factors of the resulting product where the sum is equal to b. So in this case, we have 9 and 2. If we add 9 and 2, the answer is 11. Then let b, the value of y is 9, and let z equal to 2. So by just substituting the value of a, x, and y in this formula, we will have this answer. Okay, and by simplifying, we will now have x plus 9 times x plus 2 equals 0. And by applying the zero product property, the value or the solutions are negative 9 and negative 2. Let us have another example. This time, the value of a is not equivalent to 1. And as you notice, this equation is already in standard form. So we will just go on with the next step. Let us multiply a and the value of c. So in this case, we have 6 times 8, which is 48. Then find the factors of the resulting product where the sum is equal to b. So what factors of 48 when added is equal to negative 16? So the answer is negative 12 and negative 4. If we add negative 12 and negative 4, the answer is negative 16. So this time our y is negative 12 and the value of z will be negative 4. So by using the formula, we will derive in this equation. And of course, we need to simplify this equation. Then for us to simplify the numerator, we need to factor out. And we will have this one now. And by simplifying further to cancel out the denominator, we will have this equation. Alright, so by applying the zero product property, the solutions will be 2 and 2/3. Factoring works only when the left-hand side of a quadratic equation in standard form is factorable. Study the examples below. We cannot use factoring in solving this kind of equations. So, we need to learn another method of solving quadratic equation. And this one is called extracting the square root. If the quadratic equation can be written in the form x squared equals k, it can be solved by applying the following properties. First, if x is greater than 0, then it has two real solutions, positive and negative square root of k. If x is 0, then it has one real solution, x is equal to 0. But if x is less than 0, then it has no real solutions or roots. Let us try this example. X squared minus 144 is equal to 0. Since the equation can be written in the form x squared equals k, you can apply the rules in extracting square root. So our example will become x squared equals 144. Since the value of k, which is 144, is greater than 0, then the value of x will be positive or negative square root of 144 or positive and negative 12. Let us have another example. X squared plus 49 is equal to 0. Since it is also transformable to x squared equals k, extracting the square root is possible. So in this case, we need to convert x squared plus 49 equals 0 in the form x squared equals k. And we can see that the value of k is negative 49, which is less than 0, then it has no real solution. Now, another example is this. Let us find the value of x in x squared plus 24 equals 24. Since the equation can be written in the form x squared equals k, extracting the square root is possible. And by simplifying, we will have x squared equals 24 minus 24, or x squared equals 0. Since k is equal to 0, then the solution is 0 only.